Hey guys, this is a little test prep for you. The first thing I'm going to do is have you kind of look through the packet and kind of know that anytime it says on here either AP alert or I've started, that's something you should do on a separate sheet of paper so you can be eligible for a retake. Some classes I know the stars I didn't put on there, so I'm just going to go through and star exactly. The AP alerts, I would look at those and make sure you know them. I'm going to go through and make sure you know which one should be starred first of all. So I'm going to see if this will, for some reason my page won't turn. Oh, there we go. Now it's going all at once. All right, so I'm going to take you back to page 1. And we're going to go through the packet just page by page so you know what should be starred here. So here we go. You should definitely be able to read a graph. And we talked about our limits and you kind of know that. You should know how to approach on a table using your table set feature on your calculator. I didn't star anything in this section, but right here, the bottom here, you should know when a limit fails to exist. So you might want to star that. If you approach a different number from the left than from the right, it fails to exist. Kind of gives us that. If it increases or decreases without bound, goes to infinity or negative infinity or both, or it oscillates. And this one we haven't seen happen, but if you're coming in and it keeps dinging around between two and you can't really get in there and see where it is. So make sure you know when they fail to exist. That's one thing I would have starred. And this just explains those three on this page. So we're just kind of going through the notes page by page here. All right. On this page, I would definitely kind of understand how to analyze this graph. So I would kind of take a peek and read all these and know that at f of 0, I'm just asking you what's the y value at 0. So at 0, the y value here is a negative 2. My limit as I approach 0 from the left is actually 0. Just be real comfortable with reading a graph like this. Know that in right here I've got a discontinuity happening. Know that it's not removable. I can't just redefine this point because I still have all of these going over here. Know that right here I also have a discontinuity at negative 2, but we call that removable because I can redefine that by just saying, you know what, I want f of negative 2 to equal 2, and that'll just put that dot in there, and then I'm nice and continuous again. So know these graphs right here, both for limit questions, continuity questions, and just kind of questions like what's greater or less than. So I would look that over. Next up, evaluating limits analytically. This has been a very strong point of yours. So remember that direct substitution comes first. When that fails and you get 0 over 0, remember there's some stuff to try. So when direct substitution results in 0, 0, some things to try. Know what those are. Next, this is really important, that you know what happens graphically when you divide a factor out. So this is a really key question. I would star this, and we'll go show you what problem I would like you to do. Graphically, what happens when you factor something out, like let's put one on here. Suppose it was, let's make on the top x squared minus 2x, and let's say minus 24. And maybe on the bottom I had x squared minus 36. All right, so kind of know what happens in this situation with the graph without actually looking at the graph. My denominator equals 0 at 6 and negative 6. That doesn't necessarily mean there's an asymptote there. It means there's a problem there. So we said, well, let's go factor that top into x minus 6 times, say, x plus 4. And let's factor the bottom. Make sure you always factor. Like if I were to ask you what are the vertical asymptotes for this, do not say 6 and negative 6. Make sure you factor it. Make sure you notice these cancel. So really what that means, and again this is a really important concept in this chapter, Really what you're telling me with that cancellation is you've got a removable discontinuity at 6, which basically means a hole in the graph. I have an asymptote, a vertical asymptote, at the line x equals -6. Now, if I were to ask you, well, how could you remove that discontinuity? What I'm telling you is that this function right here and this one right here agree at every point except at 6. So if I were to put a 6 in here, obviously this fails because I get a 0 on the bottom. But if I put a 6 in here, I'd get 10 over 12, or 5/6. So what that means is I can fill that hole or remove that discontinuity if I just say, you know what, I want f of 6 to equal 5/6, and I can move on my way. That's a very important concept. So again, you need to know, again, here's an AP alert, so I would do these two on your sheet. I wrote AP alert, I didn't star them, so that's kind of a little confusing, but I would do both of these. They're done in your notes. The squeeze theorem you do not need to know, but you do kind of need to know how to work with a problem like this. So you do need to know, I would star this one too. You do need to know what happens, say, when you do sine 5x over x. That I need to get the same stuff on the bottom that I'm taking the sine of in order to use this property here. That the sine of x over x is 1. So really what I do, remember, is we just said, well, we're going to divide by 5. But if I choose to do that, so I've got the same stuff here, I've got to multiply by 5. And constants come out front. So I really end up with 5 times the limit as x approaches 0 of sine 5x over 5x. And this right here is 1. So you have 5 times 1, which is 5. So know how to work with that as well. All right, and next up, and I think I did that same one on this page, so I'm going to keep moving on through here. Know your continuity. Know the 3 things you need to show for continuity. So right here, this is really important that if I ask you if something's continuous or not, and you say yes, you better show me all 3 of these reasons. You better show me it's defined at C. So if I say, is it continuous at 2, you better plug in 2 and get out an answer. You better also tell me the limit as you approach 2 from the right of your function better match up with the limit as you approach 2 from the left of your function. You also better tell me that that limit as you approach 2 is actually the same as what you got when you put 2 into the function. So again, graphically, this is kind of important. I'm going to show you what you're doing right here is telling me there's a closed dot in there. That's this one. This one's saying that I'm approaching the same from the left as I am from the right, and this one guarantees that I meet at that point. And there's my continuity, or not lifting my pencil. So that one's really important. Know the difference between removable and non-removable. Know this. It's removable if you can redefine or define that value there. Basically what it's saying is boom, 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 open hole. I can make this removable if I just fill that hole up, or if it was down here, if I just redefine it and move it up. So, all right? So also know how to deal with the piecewise functions, that if it's going to be continuous, it better meet on that fence. So you have to go take and plug that fence in there. If you get the same value, like on this one, when I put in a 0, a 1 got out. When I put in a 0 on this one, a 1 comes out. It means those functions are meeting there. So know that you need to plug those in. Sorry, Mr. Janan's in here creeping on me, and I need him to go because it's embarrassing talking when he's in here. I'll get out of here. All right, here we go. So the next one, this is a good question. I like it. So make sure you know how to read those graphs. I'm going to move on through intermediate value theorem. You might have starred this, but it's really not that one that I want starred. It's this. Make sure you know exactly how to provide an argument for why there has to be a 0 between 2 different values. And remember, you plug them each in. And I don't remember what happened on this one. I could do it really fast. I suppose I'd have 8 I get a 5 out on this one and a -1 on this one, which again, remember by the intermediate value theorem, because all polynomial functions are continuous, it's kind of necessary that you say that because we need a continuous function for this to hold. But at 2 I was 5 up, and at 1 I was -1. So if the function's continuous, it means I must have hit that x-axis. So make sure you know how to defend that. Good wording would be, because all polynomial functions are continuous, and f of 2 is 5, and f of 1 is -1, the intermediate value theorem guarantees that there must be some c between 2 and 1, such that f of c equals 0. There's got to be an x-intercept in there somewhere. All right, and then I would even star this one too. How do you find that missing a to make it continuous? Well, again, you have to make those functions meet there. So go look at how we did that. We plugged this in, and we set them equal, because we have to have the same y value, or we're not going to have continuity. There's different y values, we've got a gap. So you force the one side to match up with the other. So look at that one also. I'm at 11 minutes. So last up, what I'd also suggest you do, all right, and this is the big kicker. I told you to look at that page 94, and I told you which problems to look at. I believe it was 2 through 5, and what were the other ones? I think 7 and 10. I'm going to tell you right now that one of the tests forms has number 5 on it, and one of the test forms has number 10 on it. Okay? So kind of know that. If you make sure you know this one, make sure you know this one. Don't need to explain them quite as in detail as the packet does, but I just narrowed it down to 2 of them. Okay? Also, I already did that. I'd look at your pink graph that we did in class that I scored out of 7 points. Make sure you know how to create a graph like that. It's going to be, I'm not going to have the exact same one on there, but kind of know how to meet certain criteria. Boy, I've got things going all over here today. When you're making a graph. So if it says that your graph is supposed to go from -2 to 6, you better make sure that at -2 you have an open dot, and you better make sure that at 6 you have a closed one. I'm just going to put it on there. You better make sure that if it tells you that there's only 1 0 in here, then you better just hit the axis once. If there's 2 and they're both negative, you better go like that. You better make sure that if they tell you that it's a function, which it's going to be, you better not break your vertical line test. So whatever you do, if they tell you there's a discontinuity at 1, you better follow and make sure, you know, if it says it's approaching this one, and then just watch all those. Look at your pink sheet. And I think that's about all I have to tell you. So that ought to do. Oh, here's a good one. Actually, I would also star this because it's so tempting to put a 0 here. This is not right. The limit does not exist from the left, because when you approach from the left, you end up rooting a negative. The graph doesn't even exist there. Remember, you'll see in your notes it kind of looks like this. So I can't have a limit from both sides when my graph doesn't even exist over here. So there's some tips for you. Hopefully that goes well. Remember, in order to have a retake, you need to do those 3 things. I need the chapter review done completely with some evidence maybe that you've checked it, but chapter review done completely. The second thing you need to do is you need to go through here, and anything I just starred, you need to do on a separate sheet of paper. All right? And the third thing, what was the third thing? I have to look on my sheet. The third thing was, oh yeah, the AP problems. So that page 94, numbers 2 through 5, 7 and through 10, make sure you do those on a separate sheet. Reword them in your own wording. I already guaranteed that you're going to see either this one or this one. And then the other one I'm not going to tell you. So that ought to get you nice and well prepared. We'll see you tomorrow. Happy studying.